yet. And today we're going to determine the equation given a graph this time. Our last session we discussed how to find the equation given the given the table of values, but now we're going to be discussing about the graph. So given a graph, what is the equation of the parabola? Just by looking at it. So we can tell it's a positive equation, obviously, because A is positive because it's facing upwards. Now, what we can notice that we can see the vertex, right? We can see the vertex. So identifying the vertex in this graph, we can have and plot it here. It's somewhere within our coordinates for this -2 and +2. So that is our vertex. What other points can we identify looking at the graph? The other points we can identify looking at the graph is the y-intercept. So the y-intercept is going to be 0 and 6. So we can use that to determine the equation of the graph. How so? So if you recall, knowing that we have a vertex here, so we can use the vertex formula. So what is the vertex formula? Our vertex formula is y is equal to a times x minus h squared plus k. Okay? So we just have to substitute first our vertex in. So substituting our vertex, we have y is equal to a times x, so -2, because our h is -2, square plus 2, so our k is 2, so just copy that. So simplify, we now have y is equal to a x plus 2 squared plus 2. Okay, now looking at it, it's not incomplete. Why? We don't know what a is, right? So how do we find a? We can find a using these coordinates. So remember that this is our x point and this is our y point. So we can substitute x and y to find a in this equation. So we have a complete equation for our parabola. So let's substitute it. So our y is going to be 6. Excuse me. Our y is going to be 6. And then our a is just there, our unknown. And then our x we will substitute with 0. So 0 plus 2 squared plus 2. So simplify it following algebraic simplifications. So we have 6a 2 squared is going to be 4 plus 2. So we have 4a plus 2, 6, and transpose 2 to the other side. So we have 6 minus 2, 4a. So 4 is equal to 4a. Divide 4 for both sides. And our a is going to be 1. So if our a is 1, then we can just substitute a in this equation as 1. So our final equation as a vertex form is going to be y is equal to x plus 2 squared plus 2. So what if we want to convert it to its standard form? Because this is still in vertex form. So same procedure like our last session, just perform the FOIL method. So if we perform the FOIL method, we have y is equal to x squared plus 2x plus 2x plus 4 plus 2. Then simplify our terms. We have y is equal to x squared plus 4x plus 6. That is our standard form for this graph. Okay, from our previous example, we were able to use the vertex form to solve for the equation. So now let's look at this equation for this parabola. What we can identify is that we cannot completely identify the proper vertex form because it's in between -2 and -3, and its spot or vertex is not easily identified. So what we can do here is that we can identify the x-intercepts. So looking at the x-intercepts, we have -1, -1 and 0. That's the first root. And the other one is 2 and 0. So what else can we identify? We can even identify the y-intercept, which is -0 and -2. Using all of these equations, we can use the equation y is equal to a times x minus x sum 1 and x minus x sub 2. So what is x sub 1 and x sub 2? So x sub 1 and x sub 2 will be root 1 and root 2. So what is the root 1 and root 2? So these are our roots that we have identified. So we'll label this as x1, root 2 and 0. We'll label this as x sub 2. And then for our y and a, our y and x, we can actually look at our y-intercept. So for the y-intercept, so our y is going to be the y in the y-intercept, which is negative 2. Y is going to be negative 2 for this equation. Okay, so now we have these equations and all of their parts. X sub 1 is going to be negative 1, x sub 2 is going to be 2, y is going to be negative 2, and x is going to be equal to 0. So substituted in this formula. So y is negative 2, so we have negative 2. A is our unknown, that's what we're going to be finding out. Then for x is our 0, so we have 0. So negative times negative 1, so we have positive 1. And then we have x as 0 again, and then x sub 2 is going to be plus 2. Negative 2, because the negative side is positive. So simplify all of our terms. So we now have a, then 1 times negative 2, negative 2. So we have negative 2a and negative 2. So divide by 2 both sides, divide by 2. So we now have 1a. So that is our a for this equation. So now we have our a for this equation. We can now write it out. A 1y is equal to x minus plus 1, because negative times negative is now plus 1. And then we have x negative 2. So we have this equation. So we just have to perform FOIL method again to get our standard form. So the standard form will be x is equal to x squared minus 2x plus x negative 2. So simplify our equations. We now have y is equal to x squared negative x negative 2. So this is our equation for this graph. And that's it. And today's topic is we're going to finally discuss how to find the equation given the zeros for the roots of the function. So we'll take this example. Zeros or roots are 7 and negative 3. So we need to remember this function or this formula. F of x is equal to x negative x sub 1 times x negative x sub 2. If you recall, this equation is quite familiar to the previous example with the graph, because the difference is we just don't have the y-intercept. But all we have to do is substitute these values into this equation and then FOIL method them, and we will get the equation for this function. So doing that, we'll label this as x sub 1 and we'll label this as x sub 2. So we have x minus 7 times x negative 3. Okay, so this becomes positive 3, x plus 3, and then we just have to perform FOIL method. So performing FOIL method, we now have x squared plus 3x negative 7x and negative 21. So simplify that. We have x squared negative 4x and negative 21. That is our function given the roots. So that's just that simple. Those two numbers, we just have to substitute it in this function, and we have our final answer. And that's it.